Area classification in a natural gas processing plant is crucial for ensuring safety and preventing explosions. Based on the information provided, outdoor areas where natural gas is present are likely classified as Class 1, Division 1. The tank farm area presents a more complex situation. Within 10 feet of the tanks, it's typically considered Class 1, Division 1, while beyond 10 feet it transitions to Class 1, Division 2. Areas where natural gas is not present may still be classified as Class 1, Division 2 due to potential migration of vapors. When it comes to conduit requirements, the National Electrical Code, or NEC, dictates specific measures for hazardous locations. In Class 1, Division 2 areas, rigid conduit is generally required for raceways containing conductors that may produce arcs or sparks during normal operation. This particularly applies to motors with substantial horsepower ratings such as 200 horsepower or more. In Class 1, Division 1 areas, all raceways must adhere to stricter requirements, typically mandating the use of rigid conduit or explosion-proof fittings to contain any potential ignition. Now, regarding the specific case of a tank located in a partially enclosed area, determining the appropriate classification for the area outside the wall requires careful consideration. Due to the potential for vapor accumulation, it is prudent to err on the side of caution and treat the area as Class 1, Division 2. Consequently, rigid conduit would be necessary for the raceway containing the motor conductors running along the opposite side of the wall. Several additional considerations are vital in these hazardous environments. Firstly, grounding and bonding must be meticulously performed in accordance with the applicable codes and standards to minimize the risk of static discharge and stray currents. Secondly, explosion-proof motors and other equipment specifically designed and certified for use in Class 1, Division 1 areas must be employed to prevent ignition of flammable vapors. Thirdly, adequate ventilation is paramount to prevent the buildup of explosive vapors, especially in enclosed or semi-enclosed spaces. This general assessment is based on the information available. Consulting with a qualified professional to determine the specific area classifications and installation requirements for a particular facility is always advisable. Let's delve deeper into each of these aspects to provide a more comprehensive understanding. Considering area classification more closely, Class 1 locations are those where flammable gases or vapors are, or may be, present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 signifies that the hazardous material is present under normal operating conditions, frequently present, or may exist due to frequent repair or maintenance operations or leakage. Division 2 indicates that the hazardous material is not normally present in explosive concentrations but may exist accidentally. The classification of areas around storage tanks takes into account the potential for leaks, spills, and releases of natural gas. The 10-foot rule is a common guideline, but the specific distances may vary based on local codes, ventilation conditions, and the properties of the gas being handled. Moving on to conduit requirements, rigid metal conduit, or RMC, provides a robust, fire-resistant enclosure for electrical conductors. It's designed to withstand physical damage and contain explosions or fires within the conduit system. Explosion-proof fittings, also known as flame-proof enclosures, are designed to prevent the propagation of an explosion from within the enclosure to the surrounding atmosphere. They are typically required in Class 1, Division 1 locations to contain any potential ignition. Grounding and bonding are essential safety measures to prevent electrical shock and minimize the risk of static discharge. Grounding provides a path for fault currents to flow back to the source, tripping circuit breakers and energizing the circuit. Bonding connects all metal parts of the electrical system together to create an equipotential plane, preventing voltage differences that could cause a shock. Explosion-proof equipment is specifically designed and certified to prevent ignition of flammable vapors. These devices feature robust enclosures, sealed components, and other safety features to contain any potential explosions. Ventilation is a critical factor in reducing the concentration of flammable vapors. Natural ventilation can be effective in outdoor areas, but mechanical ventilation may be necessary in enclosed or semi-enclosed spaces to ensure adequate air circulation and prevent the build-up of explosive mixtures. Now consider the specific case of a partially enclosed area containing a storage tank. The presence of walls can impede natural ventilation and create pockets where flammable vapors can accumulate. Therefore, a careful assessment of the ventilation conditions is necessary to determine the appropriate area classification. If the walls significantly restrict airflow, the area may need to be treated as Class 1, Division 1, even if it's located beyond the 10-foot radius. Let's discuss more about the different types of motors. Motors used in hazardous locations must be specifically designed and certified for use in those areas. Explosion-proof motors are commonly used in Class 1, Division 1 locations. These motors feature robust enclosures that can withstand an internal explosion without igniting the surrounding atmosphere. Other types of motors, such as totally enclosed fan-cooled motors, may be suitable for use in Class 1, Division 2 locations, provided they meet specific requirements for temperature and enclosure. The NEC provides detailed guidelines for the selection and installation of electrical equipment in hazardous locations. It's essential to consult the NEC and other applicable codes and standards to ensure compliance. Proper training and certification are essential for electricians and other personnel working in hazardous locations. They must be familiar with the specific requirements for area classification, equipment selection, installation, and maintenance. Continuing education and refresher courses are essential to stay up to date with the latest codes, standards, and best practices. Inspections and maintenance are critical for ensuring the continued safety of electrical systems in hazardous locations. Regular inspections should be performed to identify any potential problems such as damaged equipment, loose connections, or inadequate ventilation. Maintenance should be performed on a regular basis to keep equipment in good working order and prevent failures. Record keeping is essential for documenting area classifications, equipment selection, installation inspections, and maintenance. These records can be valuable in the event of an incident or accident. They can also be used to track trends and identify potential problems before they become serious. In conclusion, working with electrical systems in hazardous locations requires a thorough understanding of area classification, equipment selection, installation, and maintenance. Following the applicable codes and standards, providing adequate training, and implementing a robust inspection and maintenance program are essential for ensuring the safety of personnel and protecting property. Remember that this information is intended for educational purposes only and should not be considered a substitute for professional advice. Consulting with a qualified professional is always recommended before making any decisions about electrical systems in hazardous locations. The specific requirements for a particular facility may vary depending on local codes, regulations, and the specific hazards present. Let us elaborate further on grounding and bonding techniques. Grounding is achieved by connecting the metal parts of the electrical system to a grounding electrode, such as a ground rod or a metallic water pipe. This provides a low impedance path for fault currents to flow back to the source, tripping circuit breakers and energizing the circuit. Bonding is achieved by connecting all metal parts of the electrical system together using bonding jumpers or other approved methods. This creates an equipotential plane, preventing voltage differences that could cause a shock. The size of the grounding and bonding conductors must be selected based on the size of the circuit conductors in accordance with the NEC. The grounding electrode must be installed in accordance with the NEC requirements, ensuring that it provides a reliable connection to earth. Proper grounding and bonding are essential for preventing electrical shock and minimizing the risk of static discharge, especially in hazardous locations where flammable vapors may be present. Let's discuss explosion-proof equipment in greater detail. Explosion-proof equipment is designed to contain an internal explosion without igniting the surrounding atmosphere. This is achieved through the use of robust enclosures, sealed components, and other safety features. The enclosure must be strong enough to withstand the pressure of an internal explosion. The joints and seams of the enclosure must be sealed to prevent the escape of hot gases or flames. The internal components must be designed to minimize the risk of ignition. Explosion-proof equipment must be certified by a recognized testing laboratory, such as Underwriters Laboratories, or UL, to ensure that it meets the applicable safety standards. The certification mark indicates that the equipment has been tested and found to be safe for use in hazardous locations. When selecting explosion-proof equipment, it's important to choose equipment that is specifically designed for the type of hazardous location in which it will be used. The equipment must be rated for the appropriate class, division, and group. The class refers to the type of hazardous material that is present. The division refers to the likelihood that the hazardous material will be present in an explosive concentration. The group refers to the specific chemical or gas that is present. Let us discuss more on ventilation requirements. Ventilation is a critical factor in reducing the concentration of flammable vapors in hazardous locations. Adequate ventilation can prevent the build-up of explosive mixtures and minimize the risk of ignition. Natural ventilation can be effective in outdoor areas provided there is sufficient airflow. The location of the equipment should be chosen to maximize natural ventilation. Obstructions that could impede airflow should be avoided. Mechanical ventilation may be necessary in enclosed or semi-enclosed spaces to ensure adequate air circulation. The ventilation system should be designed to provide a sufficient air exchange rate. The air intake should be located in a clean air zone away from potential sources of flammable vapors. The air exhaust should be located in a safe area away from potential ignition sources. The ventilation system should be equipped with alarms to alert personnel if the airflow is reduced or stopped. Let's explore the significance of training and certification. Proper training and certification are essential for electricians and other personnel working in hazardous locations. They must be familiar with the specific requirements for area classification, equipment selection, installation, and maintenance. The training program should cover the following topics: area classification principles, hazardous location codes and standards, equipment selection and installation procedures, grounding and bonding techniques, explosion-proof equipment maintenance, ventilation system operation, emergency procedures, record-keeping requirements. The training program should be conducted by qualified instructors with experience in hazardous location electrical systems. Certification should be obtained from a recognized organization such as the International Association of Electrical Inspectors, or IE. Continuing education and refresher courses are essential to stay up to date with the latest codes, standards, and best practices. Now, we will discuss inspections and maintenance. Regular inspections are essential for identifying any potential problems, such as damaged equipment, loose connections, or inadequate ventilation. The inspection program should cover the following items: equipment enclosures, wiring connections, grounding and bonding conductors, ventilation system components, alarm systems, signage. The inspection should be performed by qualified personnel with experience in hazardous location electrical systems. Maintenance should be performed on a regular basis to keep equipment in good working order and prevent failures. The maintenance program should cover the following items: cleaning equipment enclosures, tightening wiring connections, testing grounding and bonding conductors, lubricating moving parts, replacing worn or damaged components, calibrating alarm systems. The maintenance should be performed in accordance with the manufacturer's recommendations and the applicable codes and standards. Let's address record-keeping practices. Accurate record-keeping is essential for documenting area classifications, equipment selection, installation inspections, and maintenance. The record should be kept in a safe and accessible location. The record should include the following information: area classification diagrams, equipment specifications, installation drawings, inspection reports, maintenance records, training records, certification records. These records can be valuable in the event of an incident or accident. They can also be used to track trends and identify potential problems before they become serious. Let's now discuss the importance of consulting qualified professionals. This video provided general guidance on electrical safety in hazardous locations. However, it's essential to consult with qualified professionals for specific advice and recommendations. A qualified electrical engineer can assist with area classification and equipment selection. A qualified electrical contractor can assist with installation and maintenance. A qualified safety consultant can assist with developing and implementing a comprehensive safety program. Consulting with qualified professionals can help ensure that your electrical systems are safe and compliant with all applicable codes and standards. In summary, electrical safety in hazardous locations is a complex and multifaceted issue. It requires a thorough understanding of area classification, equipment selection, installation, maintenance, and training. Following the applicable codes and standards, providing adequate training, and implementing a robust inspection and maintenance program are essential for ensuring the safety of personnel and protecting property. In addition, it's essential to consult with qualified professionals for specific advice and recommendations. This comprehensive approach will help to minimize the risks associated with electrical systems in hazardous locations and create a safe working environment. Remember to prioritize safety in every aspect of your work in hazardous locations. The potential consequences of an electrical incident can be severe, so it's essential to take all necessary precautions to prevent accidents. By following the guidance provided in this video and consulting with qualified professionals, you can help ensure that your electrical systems are safe and compliant with all applicable codes and standards. Be aware of the specific hazards associated with your work environment. Understand the properties of the flammable materials that are present. Use appropriate personal protective equipment. Follow safe work practices. Report any potential hazards to your supervisor. By working together, we can create a safe and healthy work environment for everyone. As a final note, staying informed about the latest advancements in technology and best practices for electrical safety in hazardous locations is extremely critical. There are continuous updates to codes, standards, and equipment. Ensure that you are always using the most current information so that you have the most up-to-date practices. By staying informed, you will be making sure you're doing your best in making the workplace safe.